Welcome to Olympian Cares, giving you the best in water analysis. Today we're looking at top score with chlorine and chloramine. Two ways to disinfect. They're both disinfectants. One is a primary disinfectant, that being chlorine, that kills stuff instantly. It's quicker but doesn't have as much staying power. And chloramine, which stays around longer, is a secondary disinfectant. So, are they good? Are they bad? There are different ways to disinfect. Disinfecting with either chlorine or chloramine can result in a cocktail of byproducts in drinking water. And we talked about different byproducts as well. And we've got to take a more focused look at what separates both of these disinfectants and how these disinfectant byproducts formed through the use of chloramine differ from chlorine. So, chlorination, just a quick history. The mid-19th century, scientists gained a greater understanding of sources and water contamination, and due to rapid industrialization of the 1800s, the uptick in densely populated urban zones brought concerns over the water conditions to fore. Initially, some city water systems began to implement rotary filtration systems to remove contaminants that could cause typhoid, dysentery, and cholera. And it wasn't until the 20th century that disinfectants, chlorine, chloramine, ozone would make the largest impact on reducing the outbreaks of waterborne diseases in cities, and chlorine was first added to water systems in the United States in 1908, in New Jersey, and the federal regulation of quality began in 1914, when the U.S. Health Service set standards for bacterial content in water, and chloramine was introduced in the system in Cleveland, Ohio, Springfield, Illinois, and Lansing, Michigan in 1929. Now, while effective at removing bad pathogens that discovered chlorination could generate undesirable disinfection byproducts, THMs, HHA5, and a number of DPs can cause negative long-term health effects, and the EPA introduced regulation for DBPs in 1998. So, taking a look at both of these disinfectants, chlorine versus chloramine. While technology developments have allowed for near filtration, chlorine is still the most common disinfectant used to treat American water, and chlorination has been effective in distribution line and through levels can dissipate relatively quickly within the water. Also, chloramine is a compound that contains a combination of chlorine and ammonia. 1 in 5 Americans use water treated with chloramines. The maximum concentration of chloramine allowed in drinking water is 4 parts per million. So chloramination is a weaker disinfectant, as effective as chlorine in the upfront purification of organic contaminants. The water systems can maintain good residual levels of monochloramine and purification throughout the systems. And formation of regulated DBPs like triethylamines is frequently less of a problem with chloramination compared to chlorination. However, DBPs like carcinic nitrosaminates or iodinated disinfectant byproducts can form with the use of chloramines. Government bodies like the CDC have deemed it safer to treat alternative for water supplies compared with chlorine. So basically what they're saying is, yes, it does have a bad effect, but it's better to treat the bacteria, viruses, and pathogens. But long-term health risks have not been entirely addressed. So there's 2 approaches. As we take a look, effective chloramination relies on a good sense of water conditions throughout the treatment process. There's 2 general approaches. There's the anthropometric method, and this metric method measures monochloramine and total ammonia, subtracts the monochloramine value from the total ammonia to yield the free ammonia present, and with this, some free ammonia typically remains in the water distribution system. Then there's the N-diethylpyridamine, or DPD, colorimetric method, which provides an affordable alternative to generating a full spectrum of chlorine and chloramine measurement through a progression of samplings. Then we also have the chloramine and disinfectant byproducts, or DPBs, and regulation of DPBs through the use of chloramines as an alternative disinfectant because it forms less most forming DBPs. Although the CDC and the FDA both state that chloramine causes fewer disinfection byproducts. And really, the research continues with this, with the EPA scientists taking a look more. And to take a look, while chloramine is no longer lasting disinfectant, it results in fewer, better understood, regulated disinfection byproducts. It does present a greater risk when it comes to DPBs that's not fully understood. So just to sum it up, chlorine and chloramine contain their own unique advantages and disadvantages, and whichever process is used to disinfect in your local system, disinfection byproducts remain a threat to keep in mind. So that's a very good thing to end on, and know that these are good disinfectants. They have upsides and downsides, but there can always be issues in your water, so it's always a good idea to have your water periodically tested.